into the finality on the blockchain part, 'cause I think that's really important for the future that we are envisioning with composability, and that's what Ethereum prided itself on. So when we started this paper, I was very curious myself, like when does a transaction become final? Like Jack was saying, at first it's probabilistic, and then after a period of time, it gets set in stone as an unchangeable. And after doing some math, it looks like the fastest, I mean, assuming there is no attacks on the system, roughly the fastest you can expect a transaction to go final is about 12 minutes. And the slowest you can expect is somewhere in the neighborhood of 20 minutes. So I think that's a very interesting design trade-off when you start thinking about the Ethereum roadmap with L2s and rollups and danksharding and all this stuff, that you're going to need the IBC level composability between these subsystems, but that will have a 15-ish minute delay on it, which kills a lot of the composability. So feel free to go off any of that, Jack. Kind of just
for a second. I mean, the sort of instant finality thing in Tendermint is a huge benefit for interacting with other ecosystems, and this gets down to how IBC is developed, and it really relies on light clients. And I think light clients are a really interesting piece of blockchains, because if we want blockchains to actually be decentralized, any client, i.e. a mobile phone or somebody with a very low-powered computer, should be able to verify that they are talking to the correct blockchain and do that in a performant way, without having to download gigabytes and gigabytes of data. And this is what light clients do. They allow clients like mobile phones or other sort of resource-constrained areas to download only kilobytes of data, something that's really reasonable over even shaky internet connections, and verify that the chain that they're talking to is accurate. And they would only have to do this once every week or two, potentially. So with this in mind, light clients are this very key component of decentralized systems that allow the different actors using them to verify the correctness of the different endpoints that they're talking to, and they add a lot of trust into the system. And here in Cosmos and Tendermint, we built with light clients as a first-class citizen. So it's been a major feature of the protocol that's been live since around 2019. And we put a lot of work into that. And why is that? That's because with IBC, the security from IBC comes from these light clients. This is another thing that Ethereum sacrificed with the trade-offs that they made with their consensus, was the ability to easily build light clients for the Eth2 chain. It is really, because of the large number of validators, it's extremely hard and requires advanced cryptography to succinctly verify the state of the Eth2 chain from something like a mobile phone. And that's, I think that that's really problematic. Other ecosystems, things like Solana, it's impossible to build a light client for their protocol, and that kind of has its own trade-offs. But yeah, does that sort of answer what you were asking there, Joe?
Yeah, I think you did a really great job. And then I'm I'm trying to be as unbiased as possible through this and provide the bull case for ETH, even though Jack and I are both huge cosmonauts. So the bull case for why they chose Casper
in their... I'll try not to fade ETH too hard.
No, it's fine. I'll always be here as the trying to be the moderator. You can go as hard as you want in the paint. Okay, so the reason why they, I mean, let's just all say it here. Ethereum developers are very smart people. They're incredibly intelligent, and they thought about all the consequences of their design when they made their decisions. So the trade-off of this long finality that they have, let's just say 15-minute finality, is that the network can be attacked. Like, let's say 40% of the network goes rogue and starts attacking the network. In Tendermint, the chain would just shut down, and then human consensus would be required to figure out who is the misbehaving actor, what is like the correct true chain, and then how do we do the slashing and whatever to get the chain back going. In Ethereum's case, the network would not go down, it would just start forking. And there would be different sources of truth. It'd be harder to find the source of truth, but the network would slowly start slashing the entity that was the shorter stake. So the less powerful stake would slowly start getting slashed without bringing down the network. So that makes sense if you're Ethereum and you're trying to build the global settlement layer that never goes down no matter what happens. It actually does make sense to do that. I just think once you factor in the roll up future L2s, dank sharding, all that, I think it